A small lake is stocked with a certain species of fish. The fish population is modeled by the function p of t equal 10 over 1 plus 4 times e to the negative 0.8t, where t is the number of years since the lake was stocked, and p is the number of fish in thousands. P is counted in thousands. A. Find the fish population after 3 years. B. After how many years will the fish population reach 5,000 fish? Even if we were given P equals 10 over 1 plus 4 e to the negative 0.8t, we interpret it as P is a function of t, even without the of t notation. For part A, we were given t equals 3. 3 has the unit of years, so 3 has to be t. The question asks for the fish population. There are only two variables in this equation. One is t for years, and one is p for the number of fish. And so we're looking for p when t is 3. We simply plugged in 3 into t. This is 10 over 1 plus 4 e to the negative 0.8 times t is now 3, and then put it in a calculator. Make sure we take care of the denominator properly, because if we were to input this expression into a calculator and type 10 divided by 1 plus 4 e to the negative 0.8 times 3, there are so many booby traps here. Without any correct sets of parentheses, we might do 10 divided by 1 first, which is the wrong order of operation. If anything, there should be another set of parentheses around the denominator. Put it into a graphing calculator, we see that the population is roughly 7,337 after 3 years. For part B, the question now asks for how many years, and so that is the question of t equals what. And we were given that there are 5,000 fish. It would be a mistake to plug in 5,000 and set it equal to 10 over 1 plus 4 e to the negative 0.8t. This is an incorrect setup because p is the number of fish in thousands, and so 5,000 is only 5 in this case. So we can only use 5, not 5,000. If we were to use 5,000, in this case, it would be 5,000,000, which is not what the question is intended. So make sure you read the question carefully. We're trying to solve the equation 5 equals 10 over 1 plus 4 e to the negative 0.8t. At this point, we can solve it without using a graphing calculator for now. This is the fraction on the right, and so we would set up the fraction on the left. We can think of this as cross multiply to get 5 times 1 plus 4 e to the negative 0.8t equals 1 times 10, which is 10. And so 1 plus 4 e to the negative 0.8t equals 10 over 5. But 10 over 5 is 2. And so the right hand side is 2, and the left hand side is 1 plus 4 times e to the negative 0.8t. To get to t, we need to isolate 4e to the negative 0.8t first by subtracting 1 from both sides of the equation. On the right hand side, 2 minus 1 is 1. To get to t, we need to get to negative 0.8t, and we still need to get to e, and so we would need to get rid of 4 first. e to the negative 0.8t equals 1 over 4. The left-hand side is now has a base, a simple exponential form, so we can take ln both sides of the equation. The left-hand side is ln of e to the negative 0.8t, and the right-hand side is ln of 1 over 4. ln of e collapse and it gives us negative 0.8t on the left, and the right-hand side is ln of 1 over 4. T is ln of 1 over 4 over negative 0.8. We can now use a calculator to approximate that. T is roughly 1.733, and this is the number of years. It would take almost 2 years for the population of fish in the lake to reach 5,000.